Welcome back to D-Tech. Tonight we are going to be working on this 2018 Dodge Ram or Ram ProMaster. It's 2500. It was sent to me by another shop. They have been chasing an oil pressure code that I'll put up on the screen somewhere. And they have been just done with it. They were exhausted working on it, trying to resolve this issue. Everything they've done, switched and replaced, the code is still there. So with that, he asked me if I could take a look at it, see if I can figure out what's going on and why the code keeps setting and not clearing. As far as some of the things they've done, the complete housing where the oil pressure switch is in the middle of the V section on the engine. And if I haven't mentioned, this is a 3.6 Pentastar engine. It's my first time dealing with chasing an oil pressure problem. I don't get to mess with too many of these Pentastar engines, as many of you out there probably already do. As far as that, I think they did two housings, an aftermarket one and then an OEM one. They replaced the oil pressure switch, I think, a couple times, even the pigtail for the connector. And also down below the oil pump and control solenoid for it, and still has the same issue. Alright, so one of the main things I wanted to do first off was to look at live data and just see what the oil pressure reading is, just to get an idea of maybe where to start. Just again, I'll show you. That's the trouble code that keeps setting. We back out, go to live data. Now we're key on, engine off. So we obviously are not creating any oil pressure. And that's where I wanted to start with, just to see if there is some oddball reading with the oil pressure sensor just at key on. So let's see, oil pressure, and just out of curiosity there, oil pressure sensor voltage. All right, we'll pick those, hit this, and from that, just visually, we are getting 0 voltage, which is what we are expecting, because if we were to just key on the engine off, have some weird oddball number, like say, 20 psi or something weird, or 40, 50, anything odd, it would kind of question me to take a look at the wiring or the sensor or something to that extent. We're not too far off of half a volt. I don't know the operating range. I don't know if it's a 0 to 5 volts. Actually, it looks like the range as far as the scan tool is telling us 0 to 5. Usually those sensors will go from half a volt to 4.5. So we're kind of close. Nothing too oddballish. This is probably more of a clear sign that most likely nothing wrong with the wiring, even despite the fact that they did put a pigtail on there. So I'll keep you on the scanner. I'll go ahead and start it. And right away, we clearly are making decent amount of pressure at idle. This is a cold startup, as you can see there, that we are cold. I didn't want to get it too hot, well, in case I needed to do physical testing. So let me shut it off, not get it too hot. So these are just my preliminary checks. I clearly just physically want to see if I can catch an oil pressure reading, since our trouble code is describing oil pressure problem. Okay, and so my next step, after just quickly looking at the scanner's live data, seeing that we do have oil pressure, currently at cold start, I did some digging based off the trouble code, and this is basically factory information, and I think that the important part, and I'll show you, but apparently these use a oil pump that is what they call a two-stage type of oil pump with a control solenoid that is activated by the engine computer. And so it'll create low pressure and then high pressure based off of the solenoid activation, again, all based off of what the computer is demanding. And honestly, it almost reminds me of kind of like the old school Honda VTEC systems. It's a two-stage cam, a high cam, a low cam, and it's controlled by an oil control solenoid valve. And so based off of kind of RPM, it'll want low pressure, and above a certain RPM, it'll want high pressure. And it's a simple two-wire system. It's this guy here, the engine computer, and then permanently grounded. So nothing too crazy. Obviously, if that's grounded, we know it's going to be supplying voltage. And if we read here, so you guys are more than welcome to read this description. It's telling you about the speeds and the demand based off of speed, engine speed, that is, RPM, as you can see there. And I think the important literature here is this set conditions section. Let's see, with the oil pump solenoid commanded on, the PCM either detects no current draw indicating an open or excessive circuit temperature indicating a short to ground. And so all this relevant information is pulled up for basically troubleshooting based off of that specific single trouble code that this keeps logging. Nowhere near that does it say that there is an oil pressure, physical oil pressure, let's call it level issue for displaying the trouble code. It's basically literally telling us that it has to do with this circuit for the control solenoid for the oil pump. So the code itself can be basically a little bit misleading. It can lead someone to think that we are referring to actual oil pressure issue and possibly the oil pressure sensor circuit. But based off of this, we seem to be finding out that it's not, and it's relating to that, which can also explain why any and all the parts that were thrown at it have not made any change, including the solenoid that the computer controls. So we know we have to deal with that system, but the solenoid is new and it is factory, and so we can eliminate that physical solenoid being an issue. We're going to have to check from that connector up to the computer, hopefully find an issue, especially with looking like there's ways to test that. And with that, hopefully we'll be able to make a determination. All right, guys, so off camera, I got underneath on the passenger side to try to find the solenoid connector. And it's a little bit buried. It's tucked away. I was able to find it with the mirror. It appears to be plugged in. So being that it's a little bit difficult, it's on the floor and pretty oily down there, I think I'm going to take the easy, lazy approach. Meaning, since it's a simple circuit and it goes straight to ground, I'm going to rather go up to the engine computer, easy access, unplug this connector, and just ohm from here to ground, and that'll tell me if this circuit is intact. I'm not doing any load tests or anything. I just want to know, with this plugged in currently, if from here, the starting point, over to ground, if I am completing the circuit. I think that's the approach I'm going to take and go from there. Alright, so I've got my computer connector unplugged. As far as the pin, it's the one furthest that way, fourth one in. So I'll show you that. Obviously got the meter over on ground, and I've got it to audibly make a noise when continuity is there. So we want to touch that pin, and it should go straight to ground if the circuit is there, and we should hear a beep. So let's see if I can get a good shot of this on camera. So it's the fourth one. Let's see. Let's see if I can go this way. So there's 1, 2, 3, 4. Oh, all right. Well, so that tells us one thing for now, that the circuit is indeed intact. Not really what I was expecting, but I guess we will go from there. I think now based off of the information about PCM activation, so on and so forth, we can tap in here to this line. We know we have a ground, so I'm going to stay for right now on this power side. Tap in, get the scope, also amperage, since it's watching those two things, and see what we have. Again, below a certain RPM and above a certain RPM. I think it'll be a good thing to watch that now, since we know that's new. We know that's intact. Yes, I know I haven't loaded, but I think that's where I'm going to go right now. Alright, so I've got my connections. It was a little bit of a pain because that wire is like right in the middle of the harness on that connector, but I've got the scope set up. So I'm going to go ahead and just key on engine off first. Crank it up quick. Alright, so that didn't take long. Either my connections aren't good, which I thought I double checked them, but I am getting no activity on either one. Blue is the, let me stop that. Blue is voltage, red is the amperage, and we got nothing. We definitely got some sort of static noise, but no power supply. Let's see. I am almost wondering if we're gonna have, I mean, at this point it would be that the engine computer would be the problem. Now we have to try to determine for sure, but let me just maybe double or triple check some things with connections and everything. And yeah, actually, while I've got you on camera, let's it's one thing I just thought about. So I've got a key on, and let's see if we've got activation for that in the scanner. So let's see, active test. Not sure if it's this. Let's hit no. Okay, so let's see. Oh, that's weird. Alright, so let's see. Okay. Let me hit close. So we're able to get a measurable change. So that looks to be constant. This looks to be pulse. So let's go back to toggle. Yeah, see, it's got its gaps, we'll call it. Let's go to close. That kind of stops it, and let's hit escape. I don't know if you can tell or hear it, but the throttle body seemed to be in a certain state. Let's see. So I'm gonna change my scaling. Let's see. So I'm just toggling again. Alright, looks like I'm gonna have to change my time. Let's go and do a trigger. Sure, let's see if that works. Okay, let's see. I'll pause that. It's kind of an odd looking waveform for a solenoid. It's got like a swooping curve here in the beginning. And then our voltage is not really like a pulsed. Okay, so I was just double checking, and I did experience this when taking the connector off. So that red piece there, it's kind of like a lever with the those grooves there. It wasn't sliding the kind of like the lock slides. It wasn't sliding them properly. I had to kind of push them on my own, and so installing it without that top slider deal maybe has me not fully seated there on the top compared to like that guy there. And so during testing, I think what I'm experiencing is the fact that I don't fully have it seated well. So I'm going to have to mess around with that in order to not make the wrong call. Alright guys, so a little bit after some struggle, I was able to get the connector cover on and smoothly slide those two basically slides that now move freely, and looks like I am secured properly. So let's continue with the testing. I think I'm gonna go ahead with I guess we'll continue from a key on deal here. So let's start a key on with the activation, I mean. Alright, let me go in with the scanner, and I will hit the continuous. So it still looks the same. Alright, I'll stop, hit escape, and I don't know, that's weird. I think I'll go ahead and crank the engine, but I need to change some of these settings. None. Let's change our time back this way and see. Actually, before I do that, let me clear the code. So go here. Let's see. Okay, so it's listed as active. Let's back out. Erase. Yes. Yes. Alright. Just out of curiosity. No fault. Alright. I won't cycle the key. Usually I like to, but let's go ahead and see what we get. Alright, pause that. Let's see. So, looks like the same type of activation, but we're only getting, let's see, 6 volts on our control voltage side. Let's see, our amperage side is high. At 17 amps. Alright, let me key it up, just reread the code. Okay, right away. So there's clearly something going on. That is not looking correct. And it'll log a code right away. Alright guys, so I got something to show you guys. We clearly, we picked up on this and we know this shouldn't be this way. We should not have 17 amps. And it's not like it spiked up and then the rest of the portion was lower than that. So not like a inrush type of deal, kind of like a electric motor or a fuel pump or blower motor, something to that extent. This was held the whole time. Obviously, we're getting not the correct, proper, full activation. Computer is able to see that based off of what we read on service information. So, 17 amps. Definitely way too much. And so I wanted to kind of just quickly tap on it. And what I wanted to do, just me personally, activate the solenoid. So basically adding power into the line and just quickly tapping right here on the power. But obviously, based off of that, let's see. Look at this. It got a little hot. You see that? I was not, well, I mean, I was going to say I wasn't expecting it, but based off the undeniable fact that we've got a measurable number, which is 17 amps, we can clearly see why that was a result. So I was kind of attempting to just, again, while scoping, graphing, just quickly tap, and see if we get a better square wave, but we cannot because it's the same result. because of it has to do with Ohm's law. So right now, if you see 2.7, we're in Ohm's scale. I am measuring the original solenoid that was removed. Just for testing, I cut the connector off so I can get my meter leads on there. And so that's the original solenoid, which clearly was not an issue because the code didn't change whether it's new solenoid or not. 2.7. And again, if we keep it simple, let's measure that ohms we'll measure that ohm reading, and again, it just helps quantify everything we've been gathering. Alright, so we're still on ohms. Let's get the correct pin. Let's see. Try and do this one-handed. 1, 2, 3, 4. Alright, so we've got our pin there, and we are connected to ground on the other side, and we've got 0.5. So definitely less resistance compared especially to the no good solenoid. So I would say we have a short somewhere, and that is gonna be the cause of what's going on. So computer's gonna be good. Computer's doing its job, especially with what we read from service information. No other parts you throw on here, it is going to take care of it. Our first test when we checked the circuit to ground, thinking we were going through the solenoid to ground, was sort of right, but obviously incorrect, because in a known good situation, yes, we would have gone to ground. But we obviously have a direct short to ground, so it's going to give us the same result. I guess the only way to tell the difference is if I would have, instead of checking the beat mode, looked at resistance and paid attention. But, this is where we're at, continuing to learn as we go. And next is try to find the short. Alright, so clearly I've got the connector unplugged, and I'm going to check with the meter. If it's going to ground, as you can see, still in the pin, and at this point we should have no continuity at all to ground. Alright, so I'm underneath. I'm going to wiggle the harness that I have unplugged. There we go. So I bet that the short is in this small section of wire. Alright, so you saw me connect to the vehicle, clear the codes, start it up, recheck, no codes. Naturally, just out of curiosity, I've got the scope set up with the whole, after the wire repair, and just wanted to see what it was going to look like with the same measurements, voltage and amperage. What I'm going to do is, I've got the key on, I'm going to just activate it with the scanner like we were previously and see what it looks like. So I am going to go with the constant, the open, not the toggle, here first, and do that now. So it's clearly holding it. Let's stop it. There we go. And let me try the toggle. Okay, and I can actually hear it clicking down there. So let me close it, escape, pause this, and let's just get some zoomed in views and numbers probably. Let's see. So we know it's a new solenoid. It shouldn't be shorted, and it is not. We're clearly getting the normal activation. Let's see. And 300 milliamps. Nothing, nowhere near the 17 amps. And obviously we're going to get probably our full 12 volts now, not the 6.5. Yep, 12 volts. So what is interesting and to point out is, if you remember how weird and very, very short, I had to zoom in, and how many multiple times we saw, let's call it activation attempts beforehand. And again, even the toggle is not as in fast amount and frequency, so it'll hold it for a while, off, hold it for a while. Not right now, at least it's not doing constant duty cycle. But if you remember, the computer, it just blows my mind how fast it's able to recognize the higher amperage draw, that it just right away in milliseconds just shuts itself off from continuing to supply the voltage, because it sees the crazy high amperage, and it'll try, and each time obviously amperage is shooting up, and it cuts itself. So it's a protection mode, and that's where the trouble code is generated. Clearly here, it watches the amperage, nowhere near anything high, and so it's safe enough to hold it. It's at a normal operating level. So I just wanted to capture that and sort of explain that to you guys. This is good enough. We have a fix.